Hello. Okay, yeah, now it. Oh my god, I didn't realize there was no audio. Okay. Noted that I should check that before starting the stream next time. That was silly of me. Oh well. Um, of course, there's no viewers right now, but whatever. Okay, well, we can still solve this problem. Okay, well, let's do the horizontal search first. So, for row in grid, the row is vector of characters. We're going to count how many times Xmas appears in the vector of characters. So I guess we can just have we can probably break this into I've got caps lock on, that's why it's all weird. Break this into a constant. So if it starts with Xmas, then I plus equal then found plus plus. Oh, this is not, we want to do a range. Expected bool. Okay, and we don't want to move out of this. Okay, so now we should at least find some things. I guess we'll want a constant for the reversed. SAMX. Now we'll actually want all of this to be so if reverse, then we'll do the opposite. We'll go still for every row, and we'll still go through the characters, we'll go through them backwards. So actually, I think we'll make this a bit simpler if we do. Really just want to go through every row and use a count for every column, but in here it's going to be different. So if reverse, then we're going to go through the other way. If row, I guess we want to reverse the row first. Or maybe we reverse the row up top. I wonder if there's a way to like get a good backwards slice. Let me just go to a playground for a second. Okay, well, this is actually going to reverse in place, but what I want to do is like make an iterator and then reverse it. We'll make a slice so we can reverse in reverse order, but I could also just clone. Yeah, I'll just clone it. Let it. For every row on the grid. So, of course, this needs to then be... Okay. So, now, either way, we don't want to use row, we want to use whichever... I guess we only need to clone if we're doing the reverse search. So we can just... I don't want to get too bogged down in like performance details yet, but we're still trying to solve the problem, you know? So let's just do a straightforward, easy thing here. We can always optimize it later. So if row dot, so if reverse, let mute to search equals row dot clone to search dot reverse. If to search dot starts with x must backwards. Actually, I don't think we want to reverse this, do we? Because we're going to have, you know, if we're going through, what we're looking for x must, so yeah, we just want to go through in the normal direction and search for the reverse thing. Okay, so we don't need to worry about any of this reversing stuff. So if reverse, if it starts with xmas backwards, then found plus equals 1. Okay. Cool. And I think we can even change this. We can put the reverse in here. Okay, cool. So let's see if this finds something now, right? Like this should find at least something. So when we run this test, Q1 should be non-zero. Where's the to-do? Okay, right here. Let's just change this to be 0. Yeah, okay, so we found 5 things. And let's just check that the reverse one worked. If we are only searching horizontal, oh yeah, okay, let's comment this out. So if we're only doing one of them, we find 3. And if we only do the other one, we find 2. Okay, so that each direction is finding something. Okay, great. That's a really good start. Let's see. Now we have to do the vertical searches. So it's going to be a little trickier because we're trying to search, like we're searching by column, so we want to get a character from each pod along. So I think in Rust is a way to like transpose of ecovix to make it easy to search. But we don't really need to worry about doing that because we're gonna, like the diagonal one, you won't be able to search that way anyway, so it's fine. So in this case, I think we'll just do, I guess we'll just do, previously we could search each of the inner vectors. This time we're gonna start by going through each column, and in each column we're going to search along each like sub row within that column. So let's just say for I in grid.len, or you know, so one thing I want to make sure is this is actually going to be, I'm going to swap these two. Because what we don't want to do is accidentally do the exact same, yeah, this kind of stuff is like really easy to make subtle bugs with. We don't want to accidentally do the same search, but stupider, that we did in the horizontal one. So we can probably make some different test cases to make sure we're getting this correct. But I'll do that at the end. Or maybe I should do that now. Like, what if we make a test input with only horizontal, only vertical? And we're going to have X, M, A, S, and the rest of them are going to be dumb. It's going to be, you know, Q, Q, Q. So let's, this is test Q1 verticals. This is going to be test input only vert, and it should find one thing. Right, this should be length 4, this should be length 4, and this should find something. It should find this one match. So let's just do it right now, and we know it should be 0, but then we'll fix it, and it should be positive. Oh yeah, we've got this test Q1 failed. Yep, we know that, but test Q1 found 0 things correctly. Okay, so then now let's modify this. So we're expecting 1, and then this should now become actually useful code. So we're basically going to say, you know, I think we should have an at method on the grid. I think that'll be helpful. Import grid. And let's just say self O okay. Cool. So X should be grid at ij. Okay, yeah, I have to use the hidden field. XM AS. So if XMAS so if not reverse, otherwise if reverse and okay, so we need to advance this. And we should handle these out of bounds errors here. Otherwise, we're going to get a crash. So I guess we'll have a function for the length. And the height should be then if x is greater than or equal to width, or y is greater than or equal to height. Make this an option. Okay, yeah, self.width, self.height. Okay, and then if any of these are nones, we can just continue. It's not the nicest code, but I think it should be okay. Okay. So now let's see if we did this in the right order or not by running our tests. Cool, I didn't find anything, so that means I think I may have done this stuff backwards. So that's I plus 1, plus 2, I plus 3. Nice, okay, now it found something. And I'm actually going to just do this all inline. And now let's do a reverse test. So here we're going to change x mass. And here we're going to do, this will check the reverse found it correctly. Okay, nice. Okay, yeah, and you can see that now found 8 out of the 18. So that's going up a bit. It's still entirely possible this will be subtly wrong, but that's okay. We can fix it later on. In fact, maybe it would be helpful to print out how many were found in the end. So I think that'll, yeah, let's do that. I think this will be helpful for debugging. let's only run this test. I'm gonna get rid of these, like, annoying, unused diagnostics. So should see, interesting. They both found, yeah, I was a bit worried about this. That's why I added the debugs. So when we're adding this test Q1 vertical, it should, like, only one of these should be finding something, right? There's only one instance of Xmas in there. So it should not be finding one in reverse, and also one in the forwards way. Let me just change these tests so I can run them separately. Reverse, vertical, forwards. Okay, here we found one in the reverse. And what about in the forwards test? Okay, cool. So that actually looks fine to me. And then in test Q1 overall, yep, we find 8. Okay, cool. So I think that's looking at least half decent. Let's do the next way, which is going to be the diagonals. We probably won't, I don't know if we'll get time to finish part 2, because I have a call in 22 minutes, but we'll see. We'll just see. So this is going to be pretty similar, I think. We're going to be doing diagonal iteration, though. So let's use the grid, let's use reverse. So here we're going to be adding 1 to both I and j, basically. So here we're going to call this diag top right. So these are kind of marching towards the bottom right corner. I don't know why I call it top right, but you know, 0, 0 is on the top left. This is marching towards the bottom right. And the other one, I guess we'll have to start it in the top right and march it towards the bottom left. I could write little tests for these, but I think we'll just try and submit the answer we get, and if it's wrong, that's fine. We will go and write the test at that point. So for this one, now we don't want to start it at 0, 0. We want to start it at 0, 0, n. So basically we want to like do this in reverse. And then the one that started larger, I, we want to be subtracting instead. So again, I don't know if this will actually work out correctly, but I think it'll be interesting just to try it. And again, these names are kind of very stupid function names, but that's okay. And there's a lot of repeated code, and that's also okay. We can come back and make it nicer later. Interesting. Okay, so we have got an overflow now. Okay, because we protected against overflows from going too high out of bounds, but not from going too low out of bounds. So let's just add or. Wait, it's a U size, so how can it be? What even happens if you try and subtract 1 from U size? From like a 0? Checking the playground. This might be one of those things where it depends. Well, okay. I guess we can just handle. I guess the largest value of I we can handle would be I equals 3. Because if I equaled 2, then this would be negative. So we can just start it from 3. And this will be 3, 2, 1, 0. Let's see if that magically fixes all of our problems. Okay, everything passed. So I guess we'll just run it and see what we get. That's the right answer. Boom. That's the Adam Chalmers guarantee. First time, always correct. Please don't look too closely into the history of all time, so I didn't get it correct first time. But, okay, I'm not gonna lie, I feel pretty good about this. Thank you, Taran. That's helpful now. Yeah, I think it's different in... I think you're right, it's different. The panic... Underflow and overflow perform differently in debug versus release builds. I was trying to see on the Rust playground what happened, but in the Rust playground I just tried to kind of subtract 1 from 0 U size, and that's actually a compile time warning, a compile time error, and so it didn't let me do it in the first place. So whatever. So we're gonna remove the puzzle, and I'm going to remove the input, and we're then going to do download today again, because that's just how it goes. And now, if we look at the puzzle input, we can get reload it. Yeah, now we have part 2 here. So let's just save our progress. Day 4, part 1. Good. Let's just see what Clippy has to say. No lints? Man, okay, we're on a roll today. Did you misunderstand the assignment? Almost certainly. Flip over the word search. It's not an Xmas puzzle, it's an X-mas puzzle. Oh my fucking god, seriously. So we're supposed to find 2 MASs in the shape of an X. Interesting. This will be fun. Okay, irrelevant characters have been replaced. Within the X, each MAS can be written forwards or backwards. Oh, okay. That's actually not going to be too hard. We might be able to finish this in 15 minutes. Here's the same example, but only the X masses have been kept instead. Let's see. Okay, yeah, we're looking for MASs in the shape of an X. So I guess the A just has to be in the middle. I guess there's a couple of different ways this could happen. You could have, you know, like, it's given us this example here of MAS. Yeah, it's given us this example here. And the other ways we could have it happen would be from here, we see MAS, MAS. So let's just copy this. MAS, MAS, and they can go backwards too, right? Relevant characters in place dot within each X. Within the X, each MAS can be written forwards or backwards. MAS, MAS. So that would be 1, 2, 3, 4 of them here. 1 of them here. Is this one? MAS, MAS, yep, 1 of them here. MAS, MAS, 1 of them here. Okay. Okay. Not 100% sure I like get this, but we will figure it out. Test Q2. Right. Okay, we're going to make a solve Q2 function. Okay, so what we want to do here is I think we want to look at every place the A could be and then check the 4 cells diagonally around the A to see if the M's and S's are correct. So if that's the case, we just have to do it's going to be something like this. We're not going to go from 0 to their length. We're going to go from 1, because you can't have an A in the first column. And you also can't have 1 in the last column. So we're going to do this should handle the boundary conditions. So if grid.at, why is this? Yeah, cool. So the first one, if grid.at, well, okay, no, let's do it the other way. We'll say if it's not that, then continue. Let's just do this for now. Let's print out found an A, and we'll check that we found all the A's we expected to find. So for now, let's just do found plus equal. Well, so in this puzzle, how many A's are there? There are 9 selections, so it should print out 9 times. And now let's do our Q2. Okay, so it found 17 A's. Oh yeah, but there are more A's than those 9. That was only the number of A's in the foolish, like in the stripped input. So we actually want to have a look at this full input. How many A's are there? 24 A's. But we are ignoring the ones in the boundary, of which there are 1, 2, 3, 4, 5, 6, 7. Okay, so the 24, and we remove the 7 on the boundary, so we have 17. Okay, so that's a good little sanity check, and that's fine. Okay. So if we've now found an A, now we're going to check if... Okay, well, let's just do like the first case, which is straightforward. We're going to find this. So if grid.at I minus 1, j minus 1, sum m, and grid.at I minus 1, j plus 1. No, we should be doing checking this like top half first, basically. So I plus 1, j minus 1 is equal to sum mas. Then we know that the top one is valid. And for the bottom one, yeah, let's do it like this. Top bound. This means the top mass was found. We can change the top SAM would be M. And let's check on the bottom instead. We're going to have, this will be okay, so this is like, you know, this is checking for something like, you know, mass above the X. Checking for SAM above the X. This is for mass below the X, below the A. Yeah, I mean, I think you get it. So top mass So if we have something on top, so top mass or top SAM, and on the bottom we either have bottom mass or bottom SAM, then we have something, then we found something. But could also go the other way. And we are getting pretty close to my end time, so let's see. The other way this could happen is on the left and the right. So in the left case, we're looking for This is the top left corner, so we're looking for an M there, and an S in the same column but a different row. And then backwards, same column, different row. And then on the right side, I'm going to have, starting on the, if you have like the X, to have the A here, this is on the right, a bit above, and we're going to go on the right and below. Okay. So if we have an L mass or an R mass, and here we have either, no, sorry, an L SAM. Here we need something on the right, so either a mass or a SAM. Okay, and again, I don't know if this is correct. We're just gonna fucking run the test and see. Okay, test Q2 failed. So, yep, we are undercounting them. But I think I'm out of time for this. So I hope I can figure it out later on in my day after work, but I gotta get to my work. So, didn't quite finish Q2, but I think we're definitely on the right track. Yeah, thanks Taran. I got a bounce as well, so yeah, we'll see what happens. I'll post the code on GitHub, and hopefully I figure it out by the end of the day.